The altitude is a perpendicular segment from one vertex to the opposite side. If you need to split up back there, please do. Okay? All right. So if I were to draw that, it says then the two triangles formed here are similar to the original triangle and to each other. So let's look at this picture. Basically what we have is we have a small triangle that we created, a medium triangle, and we have the large triangle, right? Let's just look at it like that. So this is the most important word right here, to realize that this is similar to this, and they're both similar to the large triangle. So I'm going to write that out. The small triangle is similar to the medium triangle, which is also similar to the large triangle. If you can keep that in your head, it'll help you today. Do you know what I mean by small, medium, large in this triangle here? We created two smaller triangles, small, medium, large. Cool? You see it? When we drew the altitude? Yeah. Pardon me?
I don't know if we really...
No, ask the question.
Is like the small similar to the large?
Yes, the small is also similar to the large. Correct. So you could say large is also similar to small. They're all similar to each other, which will help you solve stuff later. Cool? All right. Then, this is all about solving parts of right triangles. Okay? So you either are going to use this concept here, which will help you set up proportions, or you might have to use the geometric mean with the altitude and the geometric mean with the leg. So there's two little formulas that you can think about for that. But first of all, I want you to label some stuff on your triangle here. You always base the naming off of the big triangle. So we're going to call this the leg 1. The smaller leg is leg 1. The bigger leg is leg 2. You always name off the biggest triangle, okay? And then this smaller part right here is going to be called base 1. And then this part right here, where the altitude cuts it into two segments, this is going to be base 2. And then we still consider this as the what? If we're looking at the big triangle, it's the what? Hypotenuse. So something to think about here. Leg 1 is with base 1, right? And leg 2 is with base 2. See how they meet here and here? Keep that in mind, okay? Now, if you can't use similar triangles, then you might need to use this. So what this says is, if you need to, let's say, find the altitude, and let's say they give you these two base numbers. Well, you can find the altitude using the geometric mean altitude theorem, which just says that the altitude is equal to base 1 times base 2, and you square root that, depending on what numbers they give you, which we'll look at later. Okay? Now, there's also a geometric mean leg theorem, where you can use a geometric mean to find a leg length. So let's say you want to find leg 1. And let's say maybe they gave you the hypotenuse and the base number. So let's say they gave you a hypotenuse and the base number. Then you would use this formula right here. It's equal to the square root of the hypotenuse times base 1. So it's equal to the hypotenuse times the base that's closest to that leg. See, leg 1, base 1, leg 2, base 2. I bet you can guess what this would be. Leg 2. How would it be different than what's here? It's times base 2. Correct. Hypotenuse times base 2. Those are the three main things, actually similar, and these two theorems are what we're going to work with today to find different parts of triangles. All right, so first part you're going to do is just identify the similar triangles in the diagram. So geometry is a lot about being able to orientate shapes. And for some people, it's a lot easier than others. It takes me a little while. I have to look at it a little bit. So I would always start, if you have to do this, always start with the one that's kind of set up how we look. Like we always kind of see this right triangle easily, don't we? The big one? See it? So I would start with the large one and just draw it. Okay, I'm going to draw it here. D, E, F. That's the big triangle. Now I'm going to draw the medium triangle. Now notice in my big triangle I have a short side, a long side, and a hypotenuse, right? So let's look at the medium triangle, and I have to orientate it the same way as this. So here's my medium triangle. Here's the short side, correct? So that's going to be here. And then my long side's going to be here. And my hypotenuse. Now I got to label it. Short side went from E to what? So this is E, this is G, and then this is what letter? F. See how you did that? We flipped it around and we orientated it the same way. Can you see that? Okay, let's do the small one the same way. So let's see, I have a short side here on the small one, long side here. So I'm just going to kind of draw that. Short side goes from what to what? D to G. So this is D, this is G. And then it goes to what point here? E. See? Okay, so you kind of orientated that. Now let's make a similarity statement. So we're going to say, I'm going to start up here with D. I'm going to say DEF is similar to what? EGF, same order of letters. So that's an F. Yes, keep writing an E, sorry, that's an F. Is similar to then what? DGE, right? This one's E. You see it? Okay, that's no problem. That's going to be something you'll have to do. So just being able to orientate. All right, turn it over.
So that's also
Wait, that's EG or EGF?
This is EGF. That's supposed to be an F. I made a mess there. Sorry. F. Okay?
so just being able to like identify
Right.
triangles and their names correctly.
Right. Mm-hmm. And it's real important to look at short side, long side, hypotenuse when you're doing that. Short side, long side, hypotenuse. Okay? All right, turn it over here. Now, we're not going to necessarily do this, but we are going to have to find the value of x. If you keep in your mind the fact that all three triangles are similar to each other, and you kind of look and see, well, what side lengths do I have right now? Do I have all three side lengths for one of the triangles? Which one? Large, medium, or small? Large. So I have all three sides for the large. And let's just look at maybe the small triangle here. I have the hypotenuse, right? Two sides for the small. I'm wondering if I just look at the small and the large, if I can set up a ratio. So kind of look at it here. Let's try it out. Talk it out to yourself. That's what I do. I have the hypotenuse in the small triangle, and my unknown is the long side, correct? Well, I can then compare that to the hypotenuse in the big triangle and the long side, because I have those numbers. Yes? So let's set up a ratio. So I'm going to say, all right, I'm going to compare the hypotenuse to the long. And I'm going to do that with my large triangle and my small triangle. And you may not need to write this all out when you're doing your homework. I'm just doing it for teaching. So what's the hypotenuse in the large triangle? 13. And what's the long side in the large triangle? 12. And what's the hypotenuse in the small triangle? 5. Small triangle. You see it? And then what's the long side? It's my unknown, isn't it? Oh, look at that. I didn't even need to use geometric mean. I can just set up a ratio and solve for x for that one. See it? Okay. Cross multiply. 13x equals 60. Well, no, it's not. So you just, it doesn't matter. You could just leave your answer when you divide both sides by 13. You can just leave your answer as 60 over 13, and that's fine. Yes, no, sort of, for that one.
Yes.
Okay? All right, let's go on. Let's see what we have here. Again, look at the large. Do we have all the sides? Yeah. And we could use either the small or the medium because we have the hypotenuse for both. Yes? So let's just use, is this the long side, do you think, or is that the short side? Let's look at the medium triangle this time. No, let's just look at the small triangle. Small triangle here. Do you think that your unknown is the long side or the short side? It is the long. Okay? For the medium triangle, it's the short side. But for the small triangle, it's the long side. So I'm going to set up, again, the same proportion that I used before. You can use any of them. You can compare any of the two sides. It doesn't matter. So the small, I'm going to set up first. What's the long leg of this? It's the x, isn't it? Of my small triangle over my hypotenuse, which is 3. Then I'm going to use the large triangle. And the long side is what? Long leg, I should say, is what? 4 over the hypotenuse, which is what? 5. Oh, look, I can just cross multiply. I don't need to use geometric mean for this one. We're getting to it, though. Don't worry. Cross multiply. 5x equals 12. And when you divide, you could just leave it as 12 over 5. I'm not checking to see if you can convert fractions or you can do decimals or whatever. I just want to know that you can set this up now. Okay? Doable? How do you feel? Should we do a quick would you rather?
Yeah.
We'll do it after this one. Okay. All right, let's look at this. This is a 2 here. It just didn't print well. That's a 2. We have less here, don't we?
Yeah.
But that's okay. Let's take a look at what we do have. We have the hypotenuse and the short side here, correct? Of the big triangle. See it? Hypotenuse, short side. Oh, well, let's look at the little tiny, small triangle. We also have the what? Hypotenuse. We don't have it, but it's a letter that we need to find. And the, oh, maybe we can set up something. Let's try it. We'll do it both ways this time. We're going to do both. So first of all, let's just use the similar triangles here. And we're going to set up short over hypotenuse. And we're going to do it for the large triangle first. So the short side is k over 10. That's for the large triangle. If you can't see that, I'll write that here. And then we're going to do it for the small triangle. So what's the short side in the small triangle? 2 over k. Oh! In essence, we are using geometric mean here. We're just setting it up in a proportion. Let's see what this looks like when we cross multiply. When we cross multiply, we get k squared equals 20. And we can simplify that, right? Inside of a 20, there is a what perfect square? 4. What's the square root of 4? 2. And what's left underneath there? 5. So k equals 2 times the square root of 5. Beautiful, huh? Now, we need to use geometric mean also. So geomean, I'm going to abbreviate. Geomean. I want to show you both ways because you're going to be toggling between both ways when you do this homework. You might not be able to set up similar. You may not be able to set up a proportion. Okay, so I am looking for, in the large triangle, what am I looking for? Leg 1 or leg 2? The shorter leg is leg 1, right? Okay, and I know that I have in the large triangle, I have the hypotenuse and base 1. So let's look back at these formulas. I need leg 1. I can get leg 1 with the hypotenuse and base 1, can't I? So let's try that. So leg 1, or my k, is equal to the hypotenuse times leg 2 here. Oh, excuse me, leg 1. No, base 1. I apologize for the wording. That's a mess. So this is leg 1 is equal to the square root of the hypotenuse times base 1. I just got it from right here. Let's plug in what we know. Leg 1 is my k. How long is the hypotenuse? 10. How long is base 1? Remember, this is hypotenuse, this is base 1, and this is leg 1. Okay, so look, we end up with the same thing, don't we? So, look at the problem. Use whatever method you need to use to do it. Sometimes you can set up a proportion, sometimes you have to use the geometric mean. Okay? All right, let's do another one. Here, I know we were going to do would you rather, but here they're giving me the altitude, and this is my what? Base 1 or base 2 here? Base 1, and this is base 2. Okay, I need to find base 2, but I've been given the alternate and base 1. So what are the altitude and base 1? What could I use maybe? I can use this. I just need to do a little algebra. Okay? You see it? I can use this. I just need to do a little algebra. So let's write this down. Altitude is equal to the square root of base 1 times base 2. Okay, let's plug in what I know. What's the altitude? 12. Trying to get my thing to come back. Okay, and base 1 is what? And what's base 2? You have the algebra skills to solve this. How do we get rid of the square root? Yeah, look at that. Let's square both sides. Square both sides. This is 144 equals 8x. Oh, that's so easy. Now what? Do what? Divide by 8. Divide by 8. X equals 18. We have found our B2 using geometric mean. Could we set up a proportion here? Yes, we can. So I'm going to do it with you because I want you to see that you can do it either way. Similar. So here's using geomean. Here's using proportions, similar triangles. What do we have? We have in the small triangle here, we have the short leg and the long leg, don't we? And then in the medium, long leg, short. So let's set up a proportion like that. Short over long. Let's start with the small triangle. So short is 8 and long is 12. You with me?
Yep.
And then the medium triangle, what's the short leg? 12 and the long is x. And lo and behold, you end up with the same thing when you cross multiply. Divide by 8 and you get 18 again. Nifty, huh?
Yeah.
Okay, we are going to do one quick would you rather before we do this last problem. Sometimes you have to use, you might need to use the geometric mean stuff twice in these problems. Here, Will, can you focus this way? Thank you. Here, we know we have the hypotenuse, correct? And what's this thing called? It's the short leg, so it's going to be leg 1. Okay. Let's look at the formulas here. For the altitude, we need base 1 and base 2. We don't have that, do we? For leg 1, we need the hypotenuse and base 1. Don't have that either, do we? But we do have leg 1 and hypotenuse, don't we? Oh. Okay, so maybe if we find base 1, then we can do what? Find the altitude. See it? So let's find base 1 first, okay? So first, we're going to do leg 1 equals hypotenuse times base 1. So we're finding leg 1. I don't know what that is, but I do know that the hypotenuse is 25 and base 1 is what? Oh wait, I do know leg 1. That's wrong. That's 5. I don't know base 1. What do we do now? Just like we did above, what do we do now? Square both sides, correct? Yes. It's B1, sorry. B1. Thank you, thank you, thank you. Love it when people ask questions because you're paying attention. All right. Square both sides. 25 equals 25 times B1. What does B1 equal? Oh, okay. Well, let's think about that. B1 is 1 foot. How long is B2 here? 24 feet. Ah, see it? Now can we find the altitude? Using the altitude geometric mean. So second step, pretty basic. We're going to find the altitude, and that equals B1 times B2. So it would just be, 24 times 1, or vice versa, there. So it's the square root of 24. And this time we'll get it in a decimal. Does anybody know approximately the square root of 24? 4.9. You're right. So I'm going to say the altitude this time is approximately 4.9 feet. Or you could say inside of 24 is 4, right? So it could be 2 times the square root of 6 as well. All right, what do you think? Okay.